Hi, one of the most frequently asked questions, what is the best budget 3D scanner for doing the reverse engineering of the automotive part, especially thin shell plastic like this. If you're going to do a part replacement of the plastic trim in your car, it's going to come out in form of a thin shell. Part like this is quite difficult to merge because it has very small overlap area and the software cannot merge it. But this all changed now with the new version of the Creality Scan 4 version 1.2.8. They have changed a lot of things, merging of the scan much easier than before. Now the Otters and the Raptor original can scan this thin shell part and merge successfully without using the more expensive model like the Raptor Pro, Raptor X or the Smooth S1. Now the Raptor original is for $1099. Otter original is $719. Otter Lite, it has two versions. The one with the Wi-Fi 645 and the one without the Wi-Fi will cost $499. I like when the manufacturer keep update their software to support their older hardware. The user can scan on the part that they couldn't scan before. So in this video, I'm going to scan this side mirror cover by using this 3 scanner. This one is Raptor Pro, but I'm going to use the 7-line laser, which is the same module as the Raptor original. Let's see what is the difference in the workflow of this 3 scanner. So if you can use this 3 scanner to scan this part, you're likely to be able to scan most of the automotive part in your car. I'm going to make a new stand. On the other half, I'm going to use the clay to stabilize because you have both markers on the object and on the turntable, so it cannot move. It has to be very static. You can see that the preview screen from the Raptor is very sharp and clear. You can see everything, what have been scanned and what have not. So I'm trying to capture the sidewall as much as possible. Looks like the Raptors can capture quite a lot of the sidewalls because the Raptor can see the markers on the edge of the turntable. Okay, before I start to delete the excess point cloud, I will fuse it and I will fuse to scan at the same time. Okay, unlike the other 2D scanner on the market, after fusing the scan, the Creality Scan 4 1.2.8, it will output the mesh instead of the point cloud. I'm going to clean up. So I recommend that you do the cleanup after you fuse the point cloud. Unlike the Creality Scan 3, that you should you should clean up the scan before you fuse, but this is another way around. Because if you clean the scan before fusing, you may have lost some of the scan data. I have seen that before with this version of the software. Manual alignment. Okay, this hold shift key, 1, 1, and 2. It doesn't have to be exactly the same spot, just approximate so that it can run into the curve. See, click on aligned. See here, it's all aligned up quite well. Okay, let's mesh the part, 3.2 millions. Okay, this is the result. There's no seam lined, very clean 3D scan. And this part is not original part, it's a 3D printed part. So I scan the clone part. Okay, you can see that the scan data is very clean and the wall is parallel. So the merging is successful. Raptor Original is capable of scanning thin shell part like this with the update software. For the Otter, I will choose medium mode because with the medium mode, if you use a high resolution camera, but if I use a large mode, it will use a lower resolution camera. Okay, for the Otter, what I don't like is the button. The touch button sometimes is not respond to my pressing. And the Otter in the medium mode has a short sight, so it cannot see the marker on the edge of the turntable. It cannot capture the sidewall that much in the preview screen. It doesn't show a lot of detail. You can see what has been scanned, but it's not as high resolution as the preview screen from the Raptor. The tracking has improved a lot. I mean, night and day from the Creality Scan 3. Before that, I never used the Otter with the markers because it's very stutter when I track with the markers. But now, 1 year later, it has been improved a lot. I'm going to flip it to the other side. I'm going to choose a resolution 0.25 and remove the marker. Okay, something to note that when you fuse the point cloud with the infrared, we use 100% of the CPU. So it's quite different from fusing the point cloud from the blue laser, which is use laser of the CPU, and it's faster to fuse in the blue laser than the infrared. 1 and 2. You can see that the sidewall from the Otter is not much captured. Number 3 will be here. It has a large seam line. This seam line is caused by a low quality point cloud. to remove this low quality point cloud, you have to fuse it again. Okay, I need to change the resolution to 0.25 and slide the noise removal to 100%. It will remove the low confidence data, which is the edges here. It will be removed. Let's try. Okay, now you can see that the rough edge, it has been removed. Let me clean up the scan, and if I turn on the scan number 2, okay, so now we have it. Smooth scan data. So the Otter can scan this thin shell. Let me mesh it. They have a 4.3 million. That's too much. Just 3 million is enough. After merging, you can see that there is no seam line between the two scans. You see that it has no visible seam line. But after I mesh it, this is the mesh data. You can see a faint seam line stand out along the edges here. Okay, this would be the joint area. I can still see the small bump here on the curve. Point cloud export data and the mesh data is aligned. So there could be some issue with the software that after meshing. See here, there's no visible seam line, but after meshing, seam lines show up again. Guys, from the Otter, yeah, I think it is the scan is clean and the wall is parallel, so it's the merging is successful. This one from the Raptor, the edge is sharper. See the edges, but when I turn here for the Otter, the edge is a bit mushy, and this one also not so sharp. That the resolution from the Otter is less than the Raptor original. So I will scan the Otter Lite in the small mode, because if I scan this with the medium mode, it will use a larger depth camera which has a lower resolution. Small mode with the marker. The buttons on the Otter Lite is a mechanical button, so it has a feedback when you press it. So tracking is good. It's much better than when I first reviewed it. Yeah, tracking with the Otter Lite is good. And the button is more responsive than the Otter original. Okay, tracking is good. Not as good as the Raptor, but it's much better than before. The size is the same as the Otter. It's quite difficult to scan, because if I lean the angle, it will lost tracking with the markers. It's unlike the Raptors. diffuse 0.25. And for the scan number 2, I'm going to do a noise removal. Don't forget to do this. It's the same as the other. It's infrared. So if I don't do this, it's going to create a seam line. Okay, so now the seam line is all gone and the side is almost not captured. I'm not sure if a software can align this. 1, 2, number 3 is in the back here, but the overlap area is very small. I'm not sure if it can do this. It can align even with a very small overlap area. Okay, let's slice the scan from the Otter Lite. It's quite similar to the Otter. The edges here is not captured well on the extreme edge, but the wall line is quite clean, but not as clean as the Raptor. The wall is parallel, so the merging is functional. Okay, this is the aluminum block scan from the Otter. I fused it with a 0.2mm resolution, and this one is from the Otter Lite. Otter Lite was scanned with a small depth camera, and it's give a very rough surface, while the Otter give a much smoother surface. Measure the distance. This aluminum block is 150mm. The Otter give the reading 149.511, and the Otter Lite give the reading 149.625. So the Otter Lite is a little bit more accurate. Okay, let's give Metro X a try. It's not capturing the side very well. When I lean to the side, it will lose the track. Flip it over, scan the other side. Move to the next one, fusion. Let's try automatic merging. Okay, takes about 2 minutes. Okay, so look at this chicken pox. 1 year after release, they still cannot fill the marker holes. In the mesh data, it filled the hole, but when I export it as the point cloud, the hole is not filled. So if you export the Metro X scans in the point cloud format, the hole will left open like this. I noticed that there is some point cloud sticking out from the edges here, so I slice it, and I found this irregularities. The scan on the outer shell, the length doesn't match the scan on the inner shell. From this point to this point, 0.8mm discrepancy between the outer shell and the inner shell. So the two scans that I made, the outer shell is 0.8mm larger than the inner shell. The wall thickness is not parallel in this area. It's narrower. So I think the merging is not done correctly. If you look at the surface quality of the scan, the Raptor gives a smoothest surface. Next to that will be the Otter, followed by the Metro X will be number 3 for the smoothness of the surface, and the Otter Lite is give a roughest. The Raptor will give best accurate measurement. When I do the aluminum block test, 150mm, it will give a 50 micron error, And for the Otter, it gives the lowest accurate reading, 439 microns. The Otter Lite is a little bit better than the Otter, 325 microns, and the Metro X is 304 micron, so it's about 0.3 millimeter for 150 millimeter length. The Otter original give noise, even though I slide the noise removal to the maximum value, it still gives a lot of noise on the edges of the scan, while the Raptor has no noise visible, and Otter Lite give a little bit of the noise on the edges. The Otter doesn't do, right now, it doesn't do a good job. It has a noise on the boundary much higher than the Otter Lite. Okay, let's talk about the ease of use. The Raptor would be the easiest scanner to scan this part. It has a very low leaning angle, so you can lean it almost parallel to the turntable, and it can capture most of the sidewalls. You require that for merging with the next scan. So the Otter and the Otter Lite and the Metro X, it gives a similar leaning angle, so you cannot lean that much with the Otter and the Otter Lite, so it captures very small amount of the sidewall. But the Otter and the Otter Lite managed to merge successfully, and the cross-section of the wall are parallels, while the Metro X, it shows that it can merge, but when I cut the cross-section, I can see that the wall from the outer shell doesn't match the wall from the inner shell. So it gives about 0.8 millimeter gap, but the Raptors give a sharpest detail, while the Otter will have a lower resolution on the detail part. And Otter Lite is the worst for the resolution. Metro X, I think it's better than the Otter Lite. So I hope that this information can help you decide which 3D scanner should be picking up in the lowest budget. Thanks you guys for watching. See you in the next video.